This is FE Peer Review. The date is February the 27th, 2022. Exploring the Plane Shows Us the Globe. This video is something of a special request, which I'll get to in a moment. I just want to say I'm taking off tomorrow morning early, and I'll be gone for 6 weeks, so I won't be able to do much. Flatzoid FE, if you happen to be watching this, I want you to know that I have not forgotten our nice exchange of comments regarding triangle problems. And I am going to work out some thoughts on that subject while I'm on the road so that when I get back I can put something up as quickly as possible. A few others of my wonderful viewers have also sent me some very nice emails, which I'm sorry I have not responded to in a timely way. I promise to go through them all carefully, and we will work together when I come back on all kinds of interesting projects. Now, on with the show. So Alex Smith wrote, "Can you do a review of this video? Thanks," and sent me a link. And the video is one by Exploring the Plane. It's about 2 years old. He's done more recent things, but I watched it and it was a good video to review. So I'm going to go ahead and give it a quick look over. Hope you enjoy this. Exploring the Plane's video is a long-distance observation taken from North Wales looking in the direction of the Lake Districts. My compliments to Exploring the Plane in that he has done a very good, clear job of documenting his observation. He shows us his location and considers his height carefully. I haven't checked all his numbers, every elevation, every distance, but it all looks reasonable, so I think we can just accept that it's probably close enough for government work. Here he gives us his location at the bottom and the range of hills that he is going to be looking at. And then he gives us a claim that we can examine. Only 3 peaks should be visible in this mountain range. He's using infrared, by the way. He gives us a whole series of peaks and their elevations and also the hidden amounts. I'm not going to show them all. It's not necessary for our purposes. You will note one thing right away, however. He is using an Earth curvature calculator that does not include atmospheric refraction. So now I'm going to go off on a little tangent about atmospheric refraction. Since this subject comes up over and over and over and over in long-distance observations done by flat earthers, some time back I did a video devoted just to the subject of atmospheric refraction and long-distance observations. I'm not going to repeat all of that here. Instead, I'm going to provide a link to this video up there in the upper right and also down in the description. I am going to provide a quick summary. Basically, it comes down to this. Current science is that atmospheric refraction happens and affects observations such as this. Now, I say current science. That doesn't mean that it's right. It could be wrong. But it is the accepted current science, and I don't need to back that up with a lot of resources. You will find a dozen links in the description of this video to scientific papers and training manuals and all this kind of stuff from groups like the U.S. military, which they generally try to do a good job, the telecommunications industry, manuals on how radar works, how to design radar systems, how to design telecommunication systems. They all include refraction and, yes, infrared. The infrared light wavelengths, which are quite close to the visible light wavelengths, are affected by refraction. So I'm not going to go through all of that. What I'm going to say is this. If you think that all the atmospheric refraction science is wrong and therefore you can simply ignore it when you do your long-distance observations, that's fine. But if you haven't shown that that's the case, then you're putting the cart before the horse, because it is the accepted science. So if you want to ignore it, you've got to show that it can be ignored. That means to the satisfaction of the world's scientific communities that use atmospheric refraction in their work, you've got to show to them that they're wrong and get them to adopt your science on atmospheric refraction. Until that time, you haven't got a case. So if you're going to do long-distance observations and you want to ignore refraction, my advice is to start by proving that all the science around atmospheric refraction is wrong. Start with that. Otherwise, you're just going to open yourself up to this same criticism, a very justifiable criticism, again and again. All right, enough about that. Check the link in details in the description. So we're treated to a bunch of data here that does not account for atmospheric refraction, which basically invalidates the conclusions of this entire observation. However, I will continue to look at it a little bit more because it contains a delightful little snippet that proves the globe. Proves the globe. I'm supposed to use the word provides evidence for. Sometimes I get excited and carried away. So he gives us this image. On the bottom here we have his panorama that he took with his infrared camera setup and all of these peaks that are visible. And then on the top he shows us a peak finder or some kind of image like that that shows a horizon line which does not account for atmospheric refraction. And based on that horizon line there should only be 3 peaks visible. Of course the horizon line is without any merit because he hasn't accounted for refraction. Let's take just one of his examples though and take a look at it. You've got Old Man of Coniston here, and it's a good one to pick because according to him it should be 29 feet below the horizon, and that of course again is without refraction, and that's pretty near zero. So the Old Man of Coniston peak should really be just barely below the globe Earth curvature without refraction horizon. Gives us a good reference. Now let's take a look at a Earth curve calculator that does include refraction. Thank you, Walter Bislin, for your wonderful tool that has saved us all so many hours of work. Here is an Earth curve calculator that includes refraction. I have set refraction to 0, and I have put in the data from Exploring the Plains video for Old Man of Coniston observer height distance. And it tells us that, yeah, in fact, it's 2930 feet. Our target size is 2634. Our hidden is 2664, so that puts the peak at 30 feet below the horizon, 29 feet, same thing. So what happens when we include atmospheric refraction? According to current atmospheric science, we should be getting a certain amount of looming due to atmospheric refraction. And with that peak at just below the horizon, the looming we get will basically be however much of the peak is visible. So I've just clicked on standard. Here we are, standard atmospheric refraction. We've got hidden 2117, visible 517. If we recall, there was a 30 feet below, so we'll add 30 to that. 547, roughly 550 feet of the peak becomes visible due to atmospheric refraction under standard atmospheric refraction conditions. Now, if we wanted to, we could go back to this image here and try to estimate where that elevation is on the mountain, where we see the black line from the water line, and see if that's, what, 550 feet or so. We could do that. Fair amount of work. It would be certainly a fine thing to do, and people have done something similar. I'm not going to do that today because we've got something else we can look at instead. But first, I just want to, for reference, get a sense of what a bit more refraction would mean. So this is standard. It's giving us about 550 feet of looming. I'm going to put in, instead of 0.17, I'm going to put 0.3, which falls in the medium range for refraction. You see here refraction K, 0.3 medium. And now we're looking at 950 feet of looming. So those are conditions that are not out of the ordinary. They're not standard, but they're not extreme. We could well see on some days 950 feet of that mountain, just because there happens to be a little more refraction than usual. And let's pump it up one more step to 0.4. And now we see that we're looking at around 1,250 feet of the mountain, and that qualifies as strong refraction. So again, conditions that are well within natural occurrence. So it's not surprising to see a substantial amount of Old Man of Coniston. That's a perfectly normal thing. Here's the bit I really liked, though. Moving away from Old Man of Coniston, we see Red Pike, minus 392 feet, and Kirk Fell, minus 562. Now, with refraction included, both of those peaks would be and are visible. But let's take a zoom in here and take a closer look. What do you see between them? Or rather, what don't you see between them? I see a cloud that comes right down to a horizon that appears to be defined by the water line. I see no land at all. Clouds coming right down to the water. So does that mean red pike, black crag, and all the stuff on the left here is some kind of island separated from the mainland by open sea, and on the right we have Kirk Fell, which is part of the mainland? Is that what we're seeing? Because that's sure what it looks like. Well, let's find out. Here we are back in Google Earth. Our observer location is down at the bottom near Llandudno, where I'm circling the mouse. And we're going to zoom in up here. Red Pike and Kirk Fell were the two peaks we were looking at just now. And no, indeed, there is no sea between them. Red Pike is not part of an island. It's all part of the mainland, all part of the Lake District. And in fact, the two mountain peaks are quite close together, and I've drawn a path between them. I'm going to select that path, and we're going to take a closer look at it. Show elevation profile. So what do we see happening between Red Pike and Kirk Fell? A great big dip. And the low point of that dip is at around 487 feet above sea level. So, do you see 487 feet of land that should be there on a flat Earth? Right there? We should be seeing 487 feet of land if the Earth is flat, but instead we're seeing clouds come right down to the horizon. We've got the peak on each side. I could do all the math and all the drawings and all the image overlays, and we could figure out exactly where that's supposed to be, but we don't need to, because our eyes and basic data are enough to tell us it's well below the waterline. Thank you, Exploring the Plane, for giving us a beautiful image of our globe Earth. I leave you with some words from the wise. Søren Kierkegaard, Works of Love, writes, "There are two ways to be fooled. One is to believe what isn't true. The other is to refuse to believe what is true." Have a wonderful day. Please do click that like button on your way out the door. Subscribe if you haven't already. And I will probably not be able to post over the next 6 weeks. I'm glad I was able to squeeze this in before my departure. I will see you all again in April.